Great. So hello, Sam. So Sam, maybe we can start talking a little bit about you.
Yeah, I went to school up here in Vermont for mechanical engineering. And back then there weren't many companies up here that were taking fresh graduates. And as a result, and I wasn't one of the smartest kids in school either. So I had to go farther afield and find a job. And my then girlfriend and I, now my wife, we both found a job in Brooklyn. So we said, let's do it. And it was at a company called MakerBot, designing and developing 3D printers. When I was in college, I had built one from a kit that was awful, but it was a great learning experience, and I was making like little toys for my friends, and I fell in love with this world of 3D printing. So that landed me a job at MakerBot, initially in the R&D world, and then later on in design for manufacturing as a product design engineer.
I was also started my career in 3D printing. And also
It's
that,
so cool.
yeah. And
It's
I think I have a lot of co-workers that came from MakerBot. I think MakerBot just like started this whole thing. It's like, oh, this is industrial machinery, but for consumers. It's
Yeah, and it's such an
built.
interesting play. Like, you're taking something that's very precise and it has to be precise and it's true, like used to be industrial. And how do we strip away all the things that aren't required, right? So like, yes, there's precision in the linear motion systems, but it also has to be mass manufactured and shipped. We had packaging design issues all the time. Units would get
Yeah.
damaged. And I was on the R&D team. And we were doing things like taking 3D printers and modifying them to become coordinate measuring machines. So you could
Mm,
actually put a build plate in, it would measure the build plate and tell you how flat or warped it was. So it was all this like really cool, like using 3D printers for non 3D printer stuff, hacking our tools together. And then later I got into design for manufacturing, plastics, sheet
I see.
metal, die casting, things like that, and loved it.
So can you tell me a little bit more like what made you stay in consumer electronics and also like what tells, a successful consumer electronics product from a one that might not stick with people?
Yeah, I mean, I've always been like a gadget guy. I love this world of like, I don't know, cutting edge electronics are so cool to me. Um, I used to, as a kid, would always get the new cell phone and then like give my parents my old one. Uh, and even before then, they had a pile of just old electronics that didn't work anymore, and I'd tear them apart and kind of learn their secrets. Um, so I've always been interested in this world of like how to build gadgets and products. I think it's fascinating and a really cool blend of design and engineering and compromises. Um, so yeah, I think that's just been really a cool world to operate in. And it's so diverse and challenging. I've worked on toilet cameras and brain scanning headsets and burrito holders. So like completely different ends of the spectrum.
Yeah.
Um,
I see like a whole
and
wall of products behind you. Are those like products you build?
these are ones that I have had a hand in at some capacity with Informal or just in my past. Um, and also like a solar powered Bluetooth speaker.
Oh, nice.
And then yeah, this burrito holder, just like a crazy variety. Um,
Do you
but
kind
you
of
asked what
roll
makes a
up and eat it without getting your hands dirty?
yeah, it's like a chopstick tube.
And look at the
Someone
size,
wants
looks like
it.
it's a super burrito size.
Oh, we measured a bunch of burritos. We figured out what will fit the Chipotle, and yeah, a lot of like it's a silly product, but a lot of work goes into something like this, right? It's really fun. And you asked what makes a good consumer electronics product.
Yeah.
Uh, I don't know. I think it's a mix of branding, design, features, right? It's this nice balance of, nobody will pay for something if it's too fancy or too complicated.
Mm,
So you need to figure out what are the minimum viable specs. You want it to look beautiful, but you don't want it to be too expensive. So we're not machining everything out of titanium. So there's a lot of design and material selection, feature selection. It's figuring out the pain points. You need to solve a need, right? Or else no one's going to buy your thing. Really fun world. And so you have some marketing input, you have engineering input, you have design input. Just trying to figure out how to massage all those and come up with the right product is a challenge.
like over the weekend, I was reading this news article talking about phones are the old consumer electronics already, and the new one is going to be some AI devices. Can you tell us a little bit more about what are the trends in consumer electronics?
We are working on so many AI devices. We see them come in our door all the time. I feel like there's been a trend of software developers who have ideas and they have access to really inexpensive development kits to put their software on their own piece of hardware. So this is a $30 development kit.
Oh, only
It's
thirty
a system
dollars.
on chip. It's got a wireless radio, battery charger, right? You can plug this in, you can write some code, and you can make your AI thing in a matter of hours. And I think a lot of software folks are coming from this world because an app, you can only do so much on an app. You have a touch screen, you have some buttons. You're limited within the box, right? So
Yeah.
if you want a button or a wearable form factor, you start designing your own custom hardware. And so I think we're seeing this trend of people saying, I don't want an app anymore. I want to make my own thing. This is making it easier, cheaper, faster. And so we're seeing this influx of software folks designing new hardware. It's very cool. I would say most of my job is, I call myself like a hardware whisperer. I'm talking to the client. I'm trying to get them to understand the timelines, complexities, requirements, acronyms in hardware. And we're seeing a big shift of new software folks coming in, right?
Yeah.
And they're used to different mentalities. And so it's a tough adjustment, I think.
Yeah, like what are the mindsets? Like software is like you, how to say, you can move really fast and you can break things, right? But hardware is like you break things, you couldn't really break things, you're liable for it, right? You can have a huge recall, or you just would never even launch, right? So
Yeah.
what mindset you feel like from software that works super well in hardware?
Yeah, well, I think the mindset of like we'll fix it later is wrong, and you can't do that,
So
right?
it's
So
actually good mindset.
that's the scary one, which is
That's a
like, oh,
scary
we can
mindset.
do a software update later and fix the fact that it catches on fire. No, you can't. That's a
Mm,
problem. So that's definitely a change in mentality of slow down, do it right the first time, check all your boxes, and once you launch and once it's out there, it's out there. Um, so that's kind of the old curmudgeon mechanical engineering brain of being like, you got to do all these things right. But I think the software team's bringing this like new energy and let's move faster. Let's
mm.
leverage new tools. Let's see what corners we can cut strategically and try and get product out faster. And so I try and find that balance of like, how fast can we go without burning a ton of money or incurring a
Yeah.
bunch of risk or shooting ourselves in the foot later on, right?
I think
Um,
software is always about this like trade-offs. In software, I don't think there's as much trade-offs you make like daily, right? I think
yeah,
software, you write a task, usually you can do it in the sprint, right? And maybe the only risk might be it would be two sprints instead of one sprint. But in
yep,
hardware, I think there's like a lot of trade-offs, right? Everything, first of all, it's going to be on a schedule. It's not going to be shipped immediately, right? It's a
yeah.
trade-off like schedules, budget, engineering time, risks. Yeah, can you tell us a little bit more, like how do you teach people about trade-offs? That's hard, right?
It's very hard and it changes depending on the use case. I'm working on a project right now where the specification is for a certain battery. So now I'm
Mm.
finding, batteries that fit our requirements, but it's too thick. So the casing gets bigger. So now we find a new battery. Is that battery certified? So like the task, change the battery or like increase the battery capacity is actually this huge thing, right?
Yes.
Find the supplier. Is it vetted? What's the dimensions? How does it impact the casing? Are there thermal concerns? Can the battery charger IC support it? What's the connector? So like under the task to change the battery is work for electrical, industrial design, mechanical engineering, and supply chain.
Oh, like
That's
very
huge.
cross-disciplinary as well, right?
Yeah, but it sounds so simple. Let's just make the battery bigger. And then you kind of pop open the project a little bit more and realize four people now have to work and coordinate on this change, where it's not just
How do
pushing a little
people,
update.
yeah, how do people coordinate? I feel I know the answer a little bit since that's basically the area I'm working on. But I'm curious, like, what's your take? How do people coordinate on that?
Well, we're an interesting use case. We are all online. So we have 450 hardware design consultants and experts that live on the internet. A lot of this is just, people who are really good at their jobs working with each other in
Yes.
Slack saying, someone says, all right, I'm going to go find 6 batteries. Here are the options. What are we going to do next? And then the electrical engineer says, I know I need to upgrade this. Firmware engineer is going to work with them, right? So it's a lot of
Yes.
people taking initiative. A good product manager, project manager is huge.
Yes.
But we also just point at someone and say, like, you're a team captain, make sure everything happens. And that comes with people having a lot of experience doing this and understanding that task of update the batteries is a big deal. and here are some tests that need to happen.
I think in my experience, I see like, say, first of all, like people who are doing hardware startups usually are people who take a lot of initiatives and are very brilliant people and very persistent as well.
Oh yeah.
And then I think like once it go beyond, let's say 15 people, when like people could not meet together in a meeting room, I think that's when like coordination, collaboration breaks down a little bit.
A lot of it. Yeah, yeah.
A lot of it.
We see it often where there's too many cooks, too many people with feedback and opinions, and the goal
Yeah,
is
yeah.
like who speaks for your team, who makes the decision for your department, or everyone's just kind of like lethargic and not like they just want to do the work. They don't want to help figure it out, right? So it's that balance of like there's a million options, for designing, let's say, a wearable AI device. There's a million trade-offs. And so who's that person saying, we're going this route and here are the pros and cons, but it's the best option,
Yeah,
period. There's a
totally.
million solutions, right? And so
Yeah.
like you need somebody to just say like, okay, I'm doing it. We're going this way until we figure something else out. And I think like that's a really valuable role to have. Just set the direction and we can change it later, but let's just go this direction for now. That's like a project manager, team lead, or someone who's been burned 1,000 times who says like, we're not going left. I've gone left before. So I've described it as a corn maze. I live in Vermont. It's corn maze season. You enter the corn maze and you're like, oh God, do we go left? Do we go right? You want someone who's been there before being like, no, I went that way. It sucks. Go this way. We don't know how to solve it. We just know like that way is bad. So the more times you do it, you're like, don't go right here. Don't go left there. The goal is to solve it as efficiently as possible.
Yeah, I think what you talk about is also related to kind of clarity around, what's an idea and what's a decision, right? And getting the people to understand what's the decision and actually having people on the same page. It sounds so easy, but I think it's not always done. Like there's so many decisions that's being made,
Yeah.
so many ideas flowing around, right? It's not like you just need to make that one decision. It's like many decisions are made at the same time and they're have interdependency and so on.
Yeah. And like, a decision like it should recognize human voice for a
Mm,
wearable. That's not really a requirement, or that's like not really a technical spec, right? Are we
yes,
using
that's
MEMS mics? Is it beamforming? Is it human voice at this distance? Is it sound cancellation? What's the range of frequencies we're detecting? Like that is the difference, I think, and that's the complexity here is turning that like customer requirement into technical numbers that the engineers can be like, I can do that, right?
yeah. And
That's really hard to
then
figure that
I
part out.
think after that, it's like you have that, but like, like your technical spec, even if you made your best decision at the time, might change, right? And when that changed, like some kind of assumption changed about certain translation, I think that's when I've seen like a lot of teams. It's just like it's so hard to coordinate because then you have like this 200 Jira tickets that's linked to
Oh
that
yeah.
assumption. How do you manage all those tickets, right? And
Yeah.
oftentimes people just have to start from scratch again, kind of going from that and but making sure, because the project has already moved forward, the interdependencies is also valid and so on.
And I think part of this, the one that really trips people up and that I've seen is, you know, using the maze analogy. They've gotten somewhere, they've solved the maze, and then I come in saying, oh, what if we went this way instead? It's a little faster. Or like, can we go this way and it still solves the maze? But they say no, because a long time ago we tried that and it didn't work. But the reason it didn't work is no longer a thing they have in their device, right? So it's
Yes.
like
Yeah.
evolving prototypes and iterations, but then they're like, we can't do this one thing. And when you push a little bit further, you realize we can now because all these other things have changed. It's really hard to like articulate, but basically it's such a evolving product.
I think it's just like to figure that out takes a lot of manual power, like manual time, like for people to actually go down the path. That's actually what
Yeah.
we want to do, ever current a little bit. I feel like there's so many like manual things people need to check and making sure it's in sync. But maybe with AI, things can be slightly better.
And I think engineers gravitate towards analysis paralysis. Like they want to know all their options. They want to know every
Yes.
single pro and con.
Yeah.
And sometimes you need someone who's a little bit more like feisty to be like, that's the one. Like that's we
Yes.
don't need to see 100 options. Here are the top five. Like that's what you need done quickly is evaluate the battlefield and choose a direction instead of like find each and every possible option.
I think, yeah, it's nice to have someone who has experience, right, to help you navigate it. But at the same time, when you're building something too new, right, you also need a little bit like fresh eyes to take a
Oh
more
yeah.
path. It's a little bit hard to tell, right, like how to do that correctly. Um,
And it depends entirely on the product. Like
yeah.
if I'm building another 3D printer, very comfortable doing that and helping. But a toilet camera that we're working on is brand new for everyone, right? Like no one's done this before. So what are the requirements? Is it waterproof? How do you clean it? Like there's just a million questions that come up and that impacts design. And no one's like, I am an expert on this. So a lot
I
of
think
research and
that's why
testing and
people, maybe that's why software people come into hardware because it's just really fun. It's a much more complicated puzzle to solve.
oh yeah. I forget who I was talking about this the other day. Oh, I was talking to the toilet person. Um, they were talking about this, and when you write code, their interaction with hardware is like, I need 6 servers spun up to do this for me.
Yeah,
That's it, right? But like in hardware world, you're like, okay, what's the SoC I'm selecting and how does that impact power management and how does that impact wireless performance and the frame rate of my camera? Like that one decision kind of is a snowball effect on the rest of your product. And so it's very different. And you need to talk to an expert who can help you digest all your needs and say, use this one for the following reasons.
So, okay, the last question, maybe a little bit about this program. It's called Miracle Repeated, right? Where we sit with experts like you or researchers to talk about how we can make the hardware miracle repeated. So, what's your advice to hardware teams on how to make that miracle, the hardware miracle, repeatable?
I think set realistic specifications and timelines. Someone described the first product you make as the minimum lovable product, and I really like that idea, which is what will get users to love your product, and that's what all you make. It doesn't have to have an app yet. It doesn't have to be the most efficient or thinnest or whatever, especially when you're pioneering a new product category. What is the key features that set you apart from everything else that make people say, here's my credit card, right?
So it's kind of like the aha moment. We talk about that in software too. Yeah.
Yeah, like the Nest thermostat, the original one is clunky and kind of weird, but it checked all those boxes where people are like, I see where this is going. This is really
Yeah,
cool.
that's right.
And now they're much thinner and made of glass and whatever. But like the original one had that idea of like, this is the direction of this industry can go. And that was the minimum lovable, right? It's, I think stripping something down to its minimum viable is actually really hard. Simplifying is harder than just like making something complex, right? It's entropy. But the simpler the user experience is, the product design, order of assembly, like all these things, the simpler it gets, the better. And so it's just choosing, so that's part of it. And then also just putting your hand down and saying, we're done, ship it. Whoever has to press that ship it button, you need someone who's like a little crazy to say like, okay, engineers, pencils down, we got to go.
Yeah.
And I think finding that balance of like, when do we launch? How long does it take? Yeah, it's a weird one.
That's great advice. Thank you so much, Sam. Thank you for coming on Miracle Repeated.
Of course, thanks for having me.